Hi, everybody, and welcome to Glow Your Own Part of If Oxford 2023. It's so great to have so many new people coming along and also some returning coders from previous years. It's brilliant that you're all getting involved. And I think there's people of all ages. There's families, people by themselves, there's little ones, there's big ones. And there's even digital ones, which someone has managed to do, which is exciting. So some avatars in there. So my name is Dane and I run If Oxford, and it's great to have back Sophie Palmer from STFC RAL and Sarah Townsend from Science Oxford, and they are veteran coders and makers and have got loads of experience with tinkering and making and breaking and fixing and breaking and fixing things. As have I, but I've just got a little bit less experience than these two wonderful women. So Sophie and Sarah are going to be leading this. Sarah's going to be helping with the chat box and doing some troubleshooting behind the scenes. Sophie is going to be leading on the instructions for the coding and the tinkering bits. You do have a chat box and you can access the chat box and you can type help, I can't get it working, and we'll come and see what we can do to help you. Hopefully you've logged into the Tinkercad classroom. I think that's it. Sophie, sorry, has put the Tinkercad classroom in the chat box there. So if you can log into that, we can then keep an eye on what you're coding and see if there's anything that needs to be adjusted. Hopefully also you've had the Tinkercad codes, which is GYO and then 3 numbers. And so if you're logging into the Tinkercad classroom, if you put those in, that's what we can identify you to. And over the course of the 6 weeks, we might get to know you through your Tinkercad code and also your screen names and also probably the range of emojis that you use. And so I do know that people like to use emojis in here and we encourage it. Okay, so hopefully that's a little bit of the technical stuff out of the way. Just as a quick reminder of how we're going to run the session, the first hour is recorded and we'll put that up on YouTube for on-demand catch-up later. And then the second part of the session is the half hour where we turn the recording off and we invite you to turn your cameras on and we can troubleshoot that way. So if you're really having trouble with some coding or some making, don't worry about it. We can always help you out at the very end, because what we want to make sure is that everybody at the end of each session has got to the end of the worksheet and all the lesson plan. So if something's looking difficult, don't worry. Follow along as best as you can, and there's no penalty for struggling. We just want to help you out at the end. So that's the most important thing for us, is that you complete the session. Okay, is that enough? Hopefully that's enough for now. So I'm going to pass on to Sophie, and so we're going to spotlight.
Hi everybody, it is wonderful to see you all. I'm so excited to be starting Glow Your Own. Dane and Sarah and I were talking just before you all joined us about how much we were looking forward to it and how we all enjoy seeing the amazing things that you create over the course of the next 6 weeks or so, and then how we can celebrate all of the amazing things that you do. So we will, don't worry, we're going to go on to Tinkercad now, and I'm going to share my screen in just a second so that we can all do it together. Just so that you know what's coming up, we're going to make sure that everyone can access Tinkercad, that we're all there, we know where everything is on Tinkercad. Then we are going to create our first circuits on Tinkercad. So we're going to create 2 circuits because I have a lot of faith in you that we can do 2 whole circuits in one day, and we're going to code them, send them instructions to Flash and to do cool things. Okay, so I'm just going to share my screen and then I'm going to check that it's the right one with everyone. Is that the right one? Yes, brilliant. Then I'm going to make you big over here. All right, so If you click on the link that was in the emails that Dane sent, but it's also in the chat, Sarah and I have popped it in the chat, you should see a screen that looks a bit like this. Then most of you should click join with nickname, because the nickname is that thing that Dane has sent to you all. So it's GYO and then 3 numbers. If you're not sure what those numbers are for you, then pop a message in this chat and Sarah or Dane will let you know. So mine is GYO 2023. So once you've typed your nickname in, you click that's me, and then you're patient for a minute while it loads up, and you're entered into the wonderful world of Tinkercad. So what we're going to be doing is we're going to be doing some coding and making some electronics in Tinkercad, but you can actually use Tinkercad to do all kinds of other things as well. So you can make designs in 3 dimensions. I'm really, really bad at that because I have a terrible sense of spatial awareness, which you'll probably notice over the course of the next 6 weeks, because I'll keep saying left when I mean right or something, but Sarah or Dane will normally correct me if I do that. So you can do all kinds of things. You can make 3D designs, you can do something called code blocks, or you can make circuits, which is what we're going to do. So once you are in this stage, we're going to click on this, create your first circuits design. If you could put a thumbs up or raise your hand or something, just to let me know that you're all at this point. I don't want to get too far ahead of most people, or you can pop an emoji in the chat or something like that, just to let me know that you are ready for the next step. Brilliant. We've got some people who are there. That is great. Thumbs up from people. We've got some emojis in the chat. Awesome. I'll just wait for another minute or two to get everyone to this point, to give you a chance to find that nickname and things, and then we'll all move on to the next step. Jolly good. Got some more hands up, some more thumbs up. Absolutely. We haven't created any activities because we're going to do that together. This is all about all of us working and doing fun stuff together. So the circuits that we're going to create today are the first step of what I'm sure is going to be an amazing project that can end up wherever you want it to. Really, when we're creating the circuits in real life, we're going to look at making Christmas lanterns or Christmas decorations over the course of this time. And I think at some point today, Dane will show you something that he has created previously, which is very, very cool. So you can see what kind of thing is possible. All right, so it looks like everyone is there, which is fantastic. So once you are all logged on, you can click on this button here. So you go down to circuits and it says create your first circuits design. You press that button and then you're patient again. And you should see a screen that looks like this. We're going to go over where all of the different bits and pieces are over the course of this lesson. But the first thing I'm going to do might sound like a bit of a boring thing, but it's incredibly useful and helpful when we're carrying on, when we go further in this session. So you can see up here, there's some words, and this is the name of your circuit. Now, Tinkercad creates some very strange names. I do not know what Super Go-Go Hillar means or how they created it, but it creates just a random name for you, and that's what it's called. It's like a file name in your computer. So I always like to change this to something that means I'm going to remember what I was doing when I created this circuit. So I'm going to call this Glow Your Own Session 1. You can name it whatever you want, but it's always, I always find it helpful to call it something that I know what it's going to be. And that means that when you're coming back and you can look, you can find your old circuits there. Brilliant. Now, what we're going to do on Tinkercad is we are going to create our circuit on the computer, and then we're going to code it. And then Tinkercad is great because we can simulate it. We can pretend run it in the computer to check that our circuit is properly set up and that our code is sending the right instructions. And the first component we're going to use is called an Arduino. Now you can see all of the different components that Tinkercad can use on the right-hand side over here. So you can see all of these different things. You can use lights, there's got batteries, you scroll down, it's got all kinds of different things. There are some motors and bits and pieces like that. And if you're not sure what any of these things are, what else is really helpful about Tinkercad is you can click on this little button here that says switch to detail view, and it gives you an explanation of what all of the different things are. So push button, a switch that closes the circuit. So it tells you what it is. A common battery. So you can find all of the different components there. We'll just be using the basic components for this, but you can switch basic to all and see all of the different things that Tinkercad can use, which contains a whole bunch of electronicsy things, and then also a potato, because why wouldn't you expect to see a potato in a thing about coding and circuits? And a lemon. We can talk about them later on if you like, why they have these lemons and potatoes. It's quite cool, actually. But we're going to concentrate on the basics to start with. So I'll switch this back to basics, and we're going to use an Arduino. So the first thing I want you to do on here is to find the one that says Arduino. And I know that, and click on it and then drag it out to the left to this area like this. And this is an Arduino. Now, I've been saying that word a lot because it's a word that I will keep saying a lot. Has anyone used them before? Can anyone tell me what they are? You can pop something in the chat if you've got an idea about what it is, what it does, if you've used it before. Any ideas? A circuit board, brilliant. Helps power the circuit, yes, absolutely. The main source. Some really good answers. Oh, Dane, Sarah, I think we're going to be able to relax a bit this year, and we'll just get them to do all of the things. This is awesome.
Absolutely.
Yeah, you can plug it into the wall. Stuff like a Raspberry Pi and a Pico, a controller board, powers the circuits. You've used it, it's a control board. Absolutely. Great answers, everybody. So what an Arduino is, it's a name for a type of small thing that you can give instructions to control other things. And the name that we give this class of like instrument or whatever is a microcontroller. Like a lot of science words, it sounds big and fancy, but actually if you look at it and break it down, it's quite, you can understand what it means. The micro part of microcontroller means it's small, because that's what micro means, and controller means it controls other things. So what we're going to use to our Arduino for is to control whatever we've connected to it, whether that is LEDs or buzzers or sensors reading in how bright it is, or whether a button's been pushed or things like that. And some of you will have physical Arduinos. I know that Dane sent out some to people, so here is mine. We're not actually going to use these ones today, but I always like to have one nearby, just in case. I'm going to zoom in for a second, just so that we can look at all of the different bits and pieces on the Arduino. So there are lots of kind of weird buttons and holes and things like this. On this side, you've got some buttons that some holes that we call pins that are digital, and they're numbered from 0 to 13. And those can either read in or send out messages to be either on or off. So we could connect an LED, a light to one of them and say, I want you to turn the light that's connected to pin 12 on, please, Arduino. And the Arduino will go, okay, and it would turn that light on. You've got some other pins over here that are called analog. And those are pins that don't have to be on or off. They can be lots of different values. So they could be, for instance, measuring, telling how bright you want a light to be shining. You could say, Arduino, I want the light that is connected to pin A3 to be really, 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 really bright. And it would go, okay, I'm going to make it really, really bright. Or you could say, actually, I don't need it to be that bright. I want it to be quite dim, and it would turn it down. You've got some ground pins, the ones that are called GND, and we'll talk a bit more about those in a second. And you've got some ones that are power. So some of the things that we're going to be using need some extra power to work. So we're going to use these power volts. These are the ones that are called a 3.3V volts and 5V or 5 volts. Okay, so that is a very quick introduction to an Arduino. By the end of the 6 weeks, you will love them as much as I do, I am sure. But does anyone have any questions? Dane's laughing at me. He loves Arduinos too.
I do. I think they're great. I do. Of course I do.
They are.
Sometimes a little bit frustrating, but they're actually really good.
That's true. Yes. They can be a bit annoying when you think they should be working and they don't, especially because normally when it's not working is because you've told it the wrong instruction and it's doing exactly what you tell it to do. So does anyone have any questions about that? No? What's the red button for? That is a really good question. So the red button is just up here, and you can see I've got a little red button on the top of mine as well. The red button normally resets your Arduino. So what you can do with an Arduino is you send it some instructions. And so you say, Arduino, I want the light that is connected to pin 4 to be turned on. And the Arduino will just carry on doing that until you tell it to stop. It will remember those instructions forever and ever and ever, unless you tell it to stop. But sometimes you've told it the wrong instructions, or it's just being a bit grumpy at you, and you want to turn it off and on again. I'm sure that any of you that have used a computer have occasionally had to just turn it off and on again. And that's what that red button does. So you can turn it off and on again, and it will just wipe its memory so it doesn't remember the instructions you've given it before. Brilliant. And yes, each of the starter kits that you get, you'll get one of these, which is good. Okay, so what we're going to do is we're going to make a circuit, and then we're going to do the instructions that tell the circuit to do whatever we want it to do. Okay, and you can take the components of your circuit, the different pieces that you want in it, and just connect them to the Arduino with wires. And that works perfectly well, but it can get a bit messy, and it can get a bit difficult because you've got to, as you'll see when we do this later on, sometimes you've got to like wrap the wires around things and then they fall off and they fall apart, and then I start being sad because it's not working. So lots of people, when they're first designing or first creating a circuit, they use this thing called a breadboard. So if you go over to the right-hand side again, you'll see a breadboard here. So if you click on that and pull that over here, we can use this to make connections between different components much more easily that work much better normally. And so you can see, and the nice thing about Tinkercad is it shows you all of those connections. So if you hover over one of the pins, one of the holes in this breadboard, you can see that, if I zoom in, you can see even more closely that I'm hovering over this one with the red square, but there are 4 other pins that are circled in green. And that's because all of those are connected to the one that I'm hovering over. So if I connected something here, it would be connected to something down here. And then the same down here, but along, but in at the bottom, they're connected along here and along here. Okay, so they just make our lives a bit easier. And I am all about making my life easier. All right, so first thing we're going to do is going to turn a light on. Are you all ready to turn our light on? Give me a thumbs up. Sarah's ready. That's good. So give me a thumbs up. Give me a wave.
Ready?
Yeah, well done. Fantastic. Lots of people are ready. So great. We are going to turn our light on. Now, when we're doing electronics, we call our lights LEDs, which stands for light emitting diodes. Electronic engineers get very grumpy if you call them light bulbs, but they're basically a light bulb. Don't tell them I said that. They're a light. So the first thing we're going to do is we're going to get our light from here. It's called an LED, and it looks like this. We're going to click on it, and we're going to pull it over to land on the breadboard. Now, it doesn't matter where on the breadboard you pop it, but I would pop it on the lower half of it. So in rows A, B, C, D, or E. I'm going to pop mine up here. And that is the first component of my circuit. Now, I really like, my favorite color is yellow. So I'm going to make this circuit have a yellow light, but you can change it to whichever color you want. So you could, I'm going to have a yellow one, but you could have a green light. It's up to you. You can do that using this little box up here. Okay. All right. So we've got our first component, which is exciting, but we need to send an instruction to it, don't we? We want to be able to send an instruction to say, turn on little light. And so we're going to connect it to our Arduino using a wire. And I'm going to connect it to pin 4. And to make a wire is really easy in an Arduino. You just click on the place you want to start, like here. So I want to start in pin 4, and then you click on the place you want to finish. So I want to start on one of the pins, one of the holes that is connected to the LED one. So I'm going to connect it over here like this. So now I can trace a path or a circuit part of the way around. So I've got my Arduino, can go through this wire up here to this LED. Now, this is perfectly fine, but I like things to be really neat, and I like things to be at right angles because I'm a bit strange like that. So if you want to change the path that your wire goes, you can double click on it in the middle. So I'm going to double click here, and then it means I can move it around. You don't have to do this, but it makes me much happier if it is nice. So I'm going to put one there so that that's a nice straight line going up. And then I'm going to put another one here. And there. Now it's all nice and neat and straight. And that just makes me happy. But you don't have to do that. Dane's looking at me like, Sophie, you're a bit crazy to do that. But it's just, it makes it look prettier.
I don't think it's that much of a bad idea, actually. Sometimes I get my coding and my wires all a bit messy, but actually having straight lines, it does make it easier to follow things through. I mean, sometimes, I look at some of my coding from a few years ago and my circuits from a few years ago, and it looks like I've scribbled on the page. And now I think I'm much neater. So
Yay.
It all comes with practice. It all comes with practice.
Jolly good. Jolly good. All right. So we are getting past part of the way there, and you can choose if you want to be as neat as me and Dane. Dane likes being neat too now, right?
A little bit, not too neat though.
Fair enough.
You'll see that with my circuit that I show you later on how neat I am.
Yeah, that's not so neat. All right. So our circuit is halfway there actually now. We've only got 2 more things to put into our circuit, which is really good. The next thing that we want to put in is called a resistor. And just to let you know, which hole it goes in doesn't really matter. what matters is that they are connected, that the different things are connected. So my wire has to be connected to this leg on the right hand side of my LED. So, and that's because otherwise the Arduino is not connected to the light and it won't be able to know where to send the instructions. So if, for instance, my wire was over here, then if I hover over that, you'll see that the green holes, none of the green holes are connected to the LED. And so it wouldn't work at all. But if I move over here, and I've just made a new wire instead of moving it, sorry, then it's connected via these green lines. So you can see that there. So the next thing we need is called a resistor. Resistors are really useful things. They just reduce the amount of power that's going through your circuit, which is good if you don't want your LED to be so bright that you blind yourself or anything, or so bright that it or to get so much that it damages the components. So we're going to use this thing called a resistor. You click on it, you pull it down, and we're going to put it here next to the wire. So you can see it's connected to the LED one there, and then it goes down to this blue line along here. Now, resistors come in different strengths, and we actually don't want our resistor to be as strong as this one is. So if you click on your resistor, you can change its value over here. They're measured in something called ohms, which is just named after someone called Mr. Ohm, I think. So you change that from K ohm, this little squiggle is an ohm. I'll just zoom in a little bit. So, no, that bit doesn't zoom in, so we can't to ohms. And then we'll make this 200. That. Okay, so our circuit is nearly complete, and that's a really important thing. Complete circuits are something that they have to be if they will work, and that just means that there is a path that goes all the way around and doesn't break anywhere. So our path so far starts in the Arduino, and then we go up along the wire. Sounds good so far, all along this wire. And then it reaches the breadboard, where it goes along the green circle lines to my LED, goes through the LED, more green circle lines to the resistor, and then it goes to this line here. So all of these. So we've got one more wire that we need to make to go back from this line all the way down back to our Arduino. And we're going to go to the ground point on the Arduino. So we're going to do one more wire from here, so it can be anywhere next to the blue line. And we're going to go to one of the pins that say ground or GND down there. Okay, now pop your hand up if you have done this and if you can trace a complete path around your circuit. So this is my path from the Arduino, up the wire, fantastic, through the LED, through the resistor, along, and then down through the wire back to the Arduino. Some of you are already there, that's amazing. Please don't worry if we are going a little bit fast. This is the first session, and so we're all getting used to it, and we're all doing it at different speeds, but we are recording this. Dane will pop the recording up and link it from the website soon, so you can always go back and have a quick look at anything that you've missed. And there's also a worksheet that has all of these diagrams on it and takes you through step by step what you need to do. So that's all good. All right, I've got lots of thumbs up. Anyone else ready? Got some more dones. More thumbs up, fantastic. Great, because in just a minute, we are going to move on to the coding part, which is my favorite bit. I like the coding bit best, because it's nice and mathsy. I'm much better at the coding part because I tend to drop things in real life on circuits and then break them. All right, so once we've got our complete circuits, it is time to code it, which means to send instructions, because that's all computer coding or computer programming is. Often you hear on the news about, what was it that Boris Johnson called it, a monster algorithm or something?
No.
Very bad. All coding is, all algorithms are a set of instructions. And we just do them in a particular language, in a particular way that everybody can understand and that computers can understand too. So that we can send those instructions. All right, and just as a reminder, the resistor value is 200 ohms. So you can change that value by clicking on the resistor and then pop it in over here, put this 200 and change that to ohms, like that. Okay, all right, now it is time for the coding. So to do the coding, the instructions, you need to go up here to the top on the right-hand side, and you click the button that says code, like this. And then this whole magical set of instructions comes out for you. Now, the first time you do it, you get some like suggested code or something, I guess. But we don't want to, we want to create our own code. We don't want to use Tinkercad's code. So we're going to delete this code, and you can delete the code in a couple of different ways. You can click on it and move it over to the left over here, which will, and then if you hover it over this bit, so essentially if you're out of the area with the code, it will disappear forever and it will make a kind of floop noise to show that it's been thrown in the bin. Or you can drag it down to this bin that's on the left-hand side here. Right, left, right, on this side here at the bottom. Sorry. And it will tell you that it's about to be thrown in the bin. So you just pull it there and then it disappears. So we get rid of that code. We don't need that code at all. We are going to create our own. And the first bit of code that we're going to do is nice and simple. We are just going to turn our LED on. So we want the Arduino to have the LED on forever. So the first bit of code that we need is in this control bit here. So some of you may have used Scratch before. This is very, very like Scratch. You've got all of these different instructions. And if you click on the different sections, I guess, you get different instructions that you can do. So we want to do a forever loop because we want our light, our LED, to be turned on forever and ever and ever and ever. So just like with the components, you click on what instruction you want. So we went to control and then the forever, and we pull it over here to the left, to the right. Sorry. I'm going to get a big L and a big R and stick them to the side of my screen so I know which direction I'm going in. Right. And so these are really useful. Those of you who have done Scratch will have used lots of forever loops before. It just means that whatever instructions you put in here, the computer or the Arduino in our case will do them forever and ever and ever and ever and ever and ever and ever. Computers are good at doing the same thing over and over again. And what we want to do is we want to turn the LED that is connected to pin 4, because I've connected my LED to pin 4 here. You can see it's connected to pin 4. We want to turn that on. And that is a kind of output. We want to send an instruction out to the, from the Arduino out to the components. So we click over here to output. And then we want to set pin to high. So you can see if you click on output, the blue one, set pin to high, you pop it in, and then you click it inside the forever loop. And you can see it makes a kind of satisfying pop noise. because it's clicked in properly. All right, so I'm just going to pause a second. If you are up there, then that's fantastic. Just let me know if you're ready for the next bit. So do a thumbs up or an emoji, or pop something in the chat. Brilliant. Oh, you guys are amazing. Oh, and that was a very cool emoji. Very snazzy. So at the moment, we've got an instruction that says set pin 0 to high. Now, if you look at my Arduino, nothing is connected to pin 0. So I could run this code and nothing would happen, because the Arduino would be like, okay, and it sends an instruction to nothing saying, be on everyone. Our light is connected to pin 4. And so I need to change this from pin 0 to pin 4. Okay. And then we get to simulate it. Now, this is one of my favorite things about Tinkercad, because it means that you can test your code and your circuit before making it in real life. So you can make sure that you've got this bit right before making the physical circuit, which is where I tend to make most of my mistakes. I make a lot of mistakes in the code as well, but even more in the physical circuit. So I know where the mistake is. Now, the fun bit in Tinkercad is, if you go up to the top, you'll see this button that says Start Simulation. And when you press the Start Simulation, it will send these instructions to our pretend Arduino on the computer, and hopefully, if we've done it right, turn our LED on. Okay, so let's all do it together. I'll count down, and then everyone press this Start Simulation button, and we will see if our lights turn on. Okay, so are you ready, Dane?
Yeah.
Good. 3, 2, 1. Yay! So you can see that my light turned on. Put a thumbs up or an emoji in the chat. Oh, or make a celebration. That's a great one.
Yes.
If your light turned on. Oh, fantastic. You're great.
Great.
If it didn't turn on, that's okay too. It often doesn't work the first time. In fact, almost always it doesn't work the first time when I'm doing it on my own.
It's also quite subtle, so it might have even turned on. So I've got a red LED, and it sort of goes from sort of a dark red to a slightly less dark red, whereas Sophie has gone for yellow, and it's way more obvious. So it might be that your LED is doing something, but it's not very obvious. So what you could do is you could stop the simulation and see if there's a change, and start it up again and see if there's another change.
Yeah.
So
I'm going to do that. So I'm going to stop it. Keep your eye on the LED. You can see it goes quite dark. And Dane's right, yellow. Perhaps that's why my favorite color is yellow for this. It's really obvious that it's on. And if you start the simulation, it goes bright again, which is fantastic. Don't worry if it didn't work. If it didn't work, pop your nickname in the chat, and Dane or Sarah can have a look at the code and the circuit that you've done, and we'll probably be able to help you out with the thing. Oh, I think Sarah dropped out accidentally, but she's back now. So we'll have a look at anyone's who's not working. But congratulations, everyone. And if it's not working, don't worry, we can fix it. Now, we're actually ahead of time, which is pretty awesome. Hi, Sarah. Oh, fantastic. We've got lots of LEDs that have turned on, Sarah, so we're all doing well. Just a couple that we need to have a tweak about. So do pop, if it's not working, then you pop your nickname in the chat, and we can have a look at it, and we will do our best to help. Oh, glowing brightly, fantastic. Yeah, sorry, just writing a message. Okay. So I think we can do the next part of our code, since you all did so brilliantly, which is a light that's always on is a bit boring for me. I want to do more things. I want things to flash and be bright and shiny and exciting. So what I want to do is I want to change the instructions that I send to my circuit to turn it on, to wait for a second, and then to turn it off, and then to turn it on again, and then to turn it off, and then to turn it on again, and then to turn it off. Okay, so we are going to use another control instruction. So we're looking in control and we want it to wait. We want to do this wait one. Because we want, sorry about that. So if we put this wait instruction in here, it will set pin 4 to high. So it'll turn our LED connected to pin 4 on, and then it will wait for 1 second. Okay, and then we want to turn the LED off. So we're going to do this outputs. We're going to use the same command, set pin. Again, it's pin 4, so we need to change the number to pin 4. But instead of saying turn it on, we want to turn it off. So you can click on the thing that says high and go to low. Okay, so we want it to turn on, wait for a second, and then turn off. Now, before I simulate it, have a think about this one. Do we think it's going to flash beautifully, or do you think there is something else that I need to do that might be a good plan? Have a think about it. And then we'll simulate it and we'll see if there's if we need to do anything. Yeah. All right. So this, I'm going to simulate it, and then we'll see what happens. So let's go click. My LED turns on, but it's not turning off again. So I need to do an extra thing. And that is because computers and Arduinos do things really, really, really quickly. Really, really, really quickly, much more quickly than we can see with our eyes. So it's saying, turn you on, set pin 4 to high, turn on, wait for a second. Okay, we can do that. Turn pin 4 to low, turn it off. But then immediately it goes back to the top of this loop and it sets pin 4 to high. So actually it is turning the light off, but it's doing it so quickly that we cannot see it. It's far too fast for us to note. So we just need another wait function, another wait instruction in there. So we pop that in. So now it will turn on, wait for a second, turn off, wait for a second, turn on, if we've done it right. So cross your fingers and we will start the simulation. Yeah. And now it's going on and off and on and off and on and off, which is brilliant and exactly what we wanted. So put your thumbs up, make a celebration emoji, pop something in the chat if it is working for you now. And if you have a beautiful flashing LED, fantastic. We've got some celebrations and some thumbs up. That is great. Oh, jolly good. If it's not working, don't worry. Just pop something in the chat and we can help you. Oh, we've got some great things for everyone. Some great emojis as well. Lots. I love the star eyes. That's great. So one thing that is quite common to go wrong is to do with these lights, these LEDs. Now, I told you that LED stood for light emitting diode. So a diode is a special kind of special kind of component that only actually works one way. So if you put it in one direction, the circuit will work and the electricity will flow through it and the light will turn on. If you put it the other way around, then it won't work. It will refuse to let any electricity pass through it, and so the light doesn't turn off. It doesn't turn on, rather. And that's a really common mistake that I make with my circuits, especially in real life. So you can see, I'm just going to stop the simulation. You can see on my LED here that the two little pins, which we call legs, are actually, they look a bit different. One is straight and one is kinked, like that. And when you get your real LEDs, you'll see that one of them, or I'm not sure you can see, one of the legs is shorter than the other. And that tells you which way around the LED should be and which way around it will work. In Tinkercad, it actually, if you hover over it, it tells you which leg is which. With the fancy words that we use, I've got no idea where these words came from, actually. I've never thought where they came from. But anyway, the one that is called, that if you hover over it, is called a cathode, goes to the ground. So that one is closest, that one needs to be closest to the ground, which it is in my circuit here. So it's closer to the ground than it is than the other one, which is called an anode. But yeah, I don't know where those words come from. Do you, Sarah? No? I always remember it because cathode has the word cat in, and I prefer dogs to cats. So I feel like that's how I remember it.
Whatever works, whatever works.
Another. So that's like adding an addition and positive. That's my way of remembering it. Never thought about the cat thing. That's a good one.
Yeah, I mean that's how I do it, certainly. Oh, fantastic, everybody. Well done. We've got lots of working LEDs, and now you can make all kinds of different circuits. Lots of different LEDs in. I think some of you have already tried adding more LEDs, which is brilliant. So in the last 10 minutes, I'm just going to add another one, just for fun, because we can, adding it. So let's move the code out of the way so that we can see our circuits. And I'm going to add another LED. So I'm going to click on my LED over here and pull it over here. And I'm going to use, it's exactly the same circuit that we're going to make, just going to replicate it a little bit further over here. And I'm going to have a red LED as my other one, I think, for today. So I've got my LED. I need to do this wire. So that goes from here. I'm going to connect it to pin 8. And then I'm going to make that a bit neater. And then I need my last resistor. Yeah. But I need to change the resistor to ohms, to 200 ohms. And if any of your LEDs weren't as bright as mine, that could be that your resistor was at a higher value. Your resistor was stronger than I set mine to. And that just means it gets less electricity, so it's not going to have as much energy, so it can't turn on as brightly. So that is 2 circuits, because I can go up from my Arduino, pin 8 along this wire, up through the breadboard, through the LED, through the resistor, along the breadboard again, and then back down this wire to the ground. Okay, so 2 LEDs. And let's see if we can get the other one turning on as well. So once you've done that, you click back on your code, outputs, and let's just set pin 8 to high, because you remember it's connected to pin 8 here. And then if I start my simulation, my yellow light should flash because it's going on and then off and then on and then off. But my red one should be on all the time. There we go. So you can do this with lots and lots of LEDs. You can add more, and we might well be doing that next session. But I think that is very nearly it for today. Remember, if you are having any problems, do pop them in the chat, and then we will also be sticking around after 6 o'clock to do some bug fixing and have a bit of a chat about all of the different things that we do with our circuits. So next time, what we are going to do is we're going to be using our real Arduinos, and we're going to make these circuits in real life, which is always very satisfying to have our light turn on and off in real life. But I think Dane has something to show us, so I'm going to hand back over to Dane so he can show you what we can achieve at the end of these few weeks. I'm just going to spotlight.
Great, thanks Sophie, so clear and such a great introduction to Tinkercad for so many new people. So I'm glad to see that many people have got it working, only a few little snags along the way. But in some ways, having little mistakes here and there or little problems here and there, actually we find that picks out some really interesting things. So I just want to show you what we've made in previous years. So I've got this wonderfully sophisticated flashing device that I've put in a cardboard box. And so you can see that this thing is sort of going around in a circle, and it looks like it's really smooth, and it looks like it's something that you might even buy in the shop. But actually, what the reality is I'll just lift my camera up so you can see inside this box. So inside is this mess of wires. So all it is that the lights go on and off and on and off and on and off, just as Sophie has done in that example, but I've set 12 of them to go on and off, and they go on and off, and so it looks a little bit like a 12-pointed circle, a 12-sided clock. And so if you have all these things wired up in a way that going around in a sequence, you can do some quite simple things and have little things, and you can just make a little casing for them that can, rather than having all the kind of wires exposed, you can make it go round and round in a circle. And I've just poked the LEDs through some cardboard using a pencil. And so we'll be doing this kind of thing over the next few weeks, encouraging you to maybe, once you've done your worksheet or done the session with us today, if you're really excited and want to do a little bit more by yourself and extend your own kind of working Arduinos by putting a few more LEDs in there or putting a few more bits of coding in there. But I think that's almost it with our time. And so we haven't got to meet Sarah yet. Sarah's been in the background busily getting things sorted. I think it might be quite nice, just as we finish, just to say hi to Sarah, and maybe Sarah can just mention who she is, what she does normally, rather than being an Arduino troubleshooting queen.
Yeah, hi everybody. So yeah, I've had loads of fun today on the chat, helping you out, getting sorted with Tinkercad and looking at your circuits, which have been really cool. But normally what I do is I work for a charity called Science Oxford, and we've got a cool science centre, and at that science centre I run lots of coding and technology workshops for lots of different people of lots of different ages, and I get to see loads and loads of cool projects. So we make lots of stuff out of cardboard, we do lots of coding, lots of circuits, and yeah, it's really good fun. So yes, I'm enjoying this. I don't use an Arduino very often, so a lot of this is very exciting for me to see a different style of coding. So I always learn something new every time we do Glow Your Own, as well as you do. So yeah.
Yeah, absolutely. We're all learning.
I think we all learn something.
Absolutely, we do.
Yeah.
But well done for today. We've done really good. We've made some good progress, and we've familiarised ourselves with the new tools, Tinkercad. And next time round, we'll be building in real life, and we'll be porting our code onto a physical Arduino board. Okay, we'll see you next time. Bye, everybody.
Bye.
Bye.